adults have pulse rate beats per minute with a mean of 72.9 and standard deviation of 12.3. The men's pulse rate is 48. So we seem to deal with the population data, the National Health Examination data. So we're gonna use mu instead of the x bar. So this x bar represents the mean of the sample, and the mu stands for the mean of the population. So we have 72.9 beats per minute, and standard deviation of the population is indicated by this Greek sigma letter, and that's 12.3. And the men's pulse rate, one of our data, will be 48. So what's the difference between the mean and the mean? So mean is 48 minus the mean. Okay, let me actually write that everything down. So x minus mu. So 48 minus 72.9, we should get, I think I've done this already. Yes, we should get 24.9 as you see in the calculator. So 24.9, and then b, how many standard deviation from this difference? We just have to divide it by the given standard deviation. And guess what? That answers part C too. So I'm gonna write the B and C together. So this is ultimately the z-score. So what's the z-score? Z-score is tells you how many standard deviation a data value is from the mean. So the higher the z-score number is, it's more unusual. So score is 48 minus 72.9 over 12.3, and I believe it's about 2. Okay, I've done this already. So negative 2.02 is our z-score value, and D is a pulse rate usual or unusual? Well, the general rule is that anything, if the number is greater than 2 or smaller than 2, I'm talking about the z-score, then it's unusual. Now in case you're not convinced by it, I can draw you a normal bell curve, assuming it's evenly distributed. You know, mean should be around at the highest apex here, and then left and right we should have the first standard deviation. Okay, so deviation distribution, and here's the mean. So for now I'm gonna the mu. Okay, and then the second one is right next to it. So you have 2 sigma and negative 2 sigma. So the width of the sigma is actually even, very uniform, and it has to be uniform. And then the area under the curve, you can assume that's just 34%, and then 13.5%, and 13.5%. So as long as a value is within the 2 sigma and the negative 2 sigma, they actually comprise 95%. However, this man has negative 2.02, he's slightly below it, therefore we consider it unusual. He's not in the 95 percentile range for from the population data. So unusual, and then we have to describe why, because statistics is always about, you know, why and how. Why? Because a person with a athletic background or many athletes tend to have lower pulse rate, so we can kind of assume the man is athlete.